HTTP data, or most data on the internet, is usually stored either on disks or in a database, and servers are programs or machines that host programs that control access to this database. Clients send requests to the machines, the server fetches the data and responds to the clients. The server that directly interacts with the database is the origin of the data, and it's called the origin server. And typically, clients interact with the servers via a proxy. For simple services, the cloud service components and the client may be in the same geographical location. However, for most modern services, this is not the case. The database, the origin server are usually located close to each other, but the proxies and the client may be in different geographical locations. In order to improve performance, it's also very typical to deploy only the proxy in the same region as that of the client, with the rest of the components in other locations. When the client makes a request, the request has to flow through to the proxy to the origin server. The origin server talks to the database and retrieves the necessary data, which then flows to the client through the proxy. HTTP has the following methods. GET is used to read data. HEAD is used to only get the headers for some data that can be read using GET. POST is usually used to create new data. PUT is to update. Patch is to update a part of some data. And delete is to delete some data. Trace and options are used for diagnostics. And connect is used to initiate tunnel connections. These methods can be categorized as follows. You have read-only methods, write methods, diagnostic methods, and special methods. Let's look at these read-only methods for a moment. When the client makes a GET request, the request follows the same path that we have described in the previous section. Now, if the client makes a GET request for the same data once again, the same steps are required to fetch the data. However, we know that GET requests do not modify data on the server. So it's a reasonable assumption that the second GET request will retrieve the same data as the first one in this example. If the same data requested via GET any number of times, assuming that data wasn't modified on the server by some other means, the same data will always be returned. So it's wasteful to make all these round trips to fetch the same data over and over again. And instead, we introduce a new database in the proxy to temporarily store the data. Now, the first time a request is made for some data, we make the full round trip to the database to fetch this data, but we also store a copy of the response in the proxy's special database. The next time the same data is requested, the proxy can fetch it from its own database and prevent the round trip. This mechanism of storing data for immediate or temporary use is called caching, and in this video we're going to look at caching of HTTP data, and particularly using proxies. This process is also called shared caching. Now, caching has a few advantages. It reduces the network bandwidth, it reduces the waiting time because you don't have to make all those round trips, and it reduces the load on the server because the server is not contacted as many times. Now, before we head into caching in HTTP, let's look at what a cache is in the first place. A cache is a special type of database that is specifically optimized for short-term data and quick access data. Caches are usually implemented as key-value pairs. A key is usually a unique string that identifies a value. The values can be strings or bytes or numbers or even in some case objects. When a program, in this case a proxy, looks for some data, if the data is found, it's called a cache hit, and if it's not found, it's called a cache miss. Since caches store temporary copies of data, at some point the original data might have been modified and this copy is no longer usable. Such data which is no longer usable is called stale data, and data that is not stale or is still relevant is called fresh data. In order to not store data infinitely on a cache, all cache entries usually have an additional parameter called the TTL, or the time to live. It's like an expiry limit after which the data becomes stale. A general HTTP GET request is as follows. You make a GET request to a certain endpoint, in this case API v1 users Alice. This endpoint and the data behind it is usually called a resource. And if the data exists, that data is returned and you get a 200 positive response, which means it was okay. And you also get the data associated with that resource. Now, if you use a proxy in between, it looks something like this. You make the same request to the proxy, which then relays it to the server. The data is retrieved from the server, which the proxy then relays back to the client. Since the HTTP GET method is read-only and does not modify the data, it's considered cacheable. Also note that head is also cacheable, but in this video we'll only focus on GET. If this proxy has caching enabled, then it can cache this message. Since cache is a key value pair, the key is usually the URI, in this case API v1 users Alice, and the value is the data for this URI returned by the origin server. In some implementations, the HTTP method, for example cache, may also be part of the cache key. For subsequent GET requests to the same endpoint API v1 users Alice, the proxy does not contact the origin server, but it checks in the cache if the same value is present. And if it is present, it basically returns the cache data. The usage of cache raises an interesting question. The data of the user Alice on the server might be modified and the proxy may not know of this. The proxy can of course keep checking with the origin server, but that defeats the purpose of caching. Remember that the point of caching was to reduce calls to the origin server. Now, when the data on the origin server is updated, the data that is stored in the cache becomes stale or outdated. And the proxy has to contact the server to retrieve this data, which is something that we want to avoid. So HTTP provides three mechanisms to ensure that the cache data does not go stale, while also trying to reduce the calls to the origin server. These mechanisms are defining freshness criteria, validation, and invalidation. Now let's look at the freshness criteria. Going back to the basic idea of a cache, there's a TTL value that defines how long a cache data is valid. Freshness criteria in HTTP is a similar concept. It's used to specify when some data that is cached is considered stale or out of date. Note that I'm only going to show a few examples of freshness can be specified and modified. There are many options and we're not going to go through all of them. The client, for example, can set a special header value called cache control and set a directive under that header called max age. Now, if you set max age to 5, which in this case is 5 seconds, the proxy checks if this data that is stored in the cache is outdated or not. It can know that by checking when was the last time this data was updated. Now, if the data was updated at a time older than 5 seconds, it can make a request to the server to fetch new data. And this data is now relayed back to the client. Similarly, the origin server can also set this cache control header to a max age value, which means that the proxy must now remember that this data is valid only for 5 seconds. Any requests that come before 5 seconds, the proxy can return the value that is cached, and after 5 seconds, it must contact the origin server to return the new updated value. And an alternative for this is using the expires header. In this case, instead of using relative seconds, you use an absolute time based on the time zone to say when this data is out of date. Another way for the proxy is to send what's called an age header, where it defines the number of seconds since the last time the proxy contacted the server to check if something was updated. The client can use this data to see if it's too old and request the data again to go through the origin server. These are just a few examples. Controlling cache freshness has many other options which are not presented here. The second mechanism to manage freshness or staleness of cache data is validation. While the freshness criteria defines when cache data is out of date, validation takes the extra step by checking if the data is modified on the upstream server and updates the cache if there has been an update. Again, there are multiple ways of doing it. Let's take one specific example. When a client sends a request to a resource, The proxy can use a special header called if modified since and set a date and ask the origin server if the data was modified since this particular date. If the data was modified, then the server will return this value and the data or the new updated data can be returned to the client. On the other hand, if the data was not modified, then the server can return a 3 or 4 with the not modified response and also set the last modified to the original value. The proxy can look up the cached value in its cache and then return that value because the original was not modified. Other mechanisms of validation, which we are not going to discuss here, include the use of things like etag headers, use if unmodified since headers, if none match, or if range. The final method of managing data freshness is via invalidations. Invalidation is a quite straightforward concept. Back to our HTTP request types, we know that you have read-only, write, diagnostic, and special types. Now, these write types are intended to modify or remove data from the origin servers, which means that these are automatically unsafe for caching since they modify the original data. If the client makes a post request through the proxy to the origin server and the origin server accepts this request via a 2xx or 200 in this case, this means that the original resource was somehow modified because it's a post request. So the proxy marks this value as invalid in the cache, and all subsequent GET requests or the first subsequent GET request will not be served using the cached value, but the proxy will contact the server to fetch the updated value. The proxy can use a warning header to warn clients of certain situations regarding the cache. Note that this is a separate header value and it's not a response status code. 110 from the proxy means that the response that it's serving is stale. 111 means that the revalidation or the validation step where you request the upstream server for new data has failed. 112 means that the proxy for some reason got disconnected from the upstream server. 214 or transformation applied means that some header values were modified by the proxy, and 299 is a general miscellaneous warning. There's a lot of information here for us to process, and we've only covered a few basic topics. I highly recommend that you take a look at RFC 7234, which has a lot more information on this topic, and this particular video was also made from a lot of information here.